Okay, so if you look at your section B, question B8 is actually quite long. There's a news article from which you will actually get some information. And there is also an infographic, okay, from which you will also be able to get quite a bit of information. So here's the problem with your section B. If you've done enough TYS questions, you'll realize that your very first or possibly second question of your section B is always a data-based question. Some years the database question is as long as 5 pages long. So if you look at this database question, right, it's actually page 14, 1 page, page 15, 2 pages. Questions over here, 3 pages, and questions over here, 4 pages. That's it. Okay, in some years, including the questions, it can go as long as 5 or even 6 pages long. So do take note of that. If you realize that you're somebody who feel very daunted by your database question, you feel like, I see already so long, don't know how to panic, then it's okay. Instead of starting off your section B with the database question, do go and do your last question first. Because your either or question from your TYS, as you can see, is usually based quite clearly on only 1 or 2 topics. So it's a lot more focused, it's easier to target, and you won't feel so overwhelmed. In the case of our section B, you realize that the last question is actually on electrolysis. And now that you have the time to calm down, you're not under exam stress, if I were to ask you to do the electrolysis question again, I think you'll realize that it's actually very manageable. Okay, this was the question that those of you who had the resilience to make it through the entire paper, you would have gotten at least 7 out of 9 marks. Okay, in fact, there were quite a lot of students in other classes who got at least 6, 7 upon 9. So this is where you really chalk up your marks. Okay, it's quite common that database questions students usually don't do too well in, so you don't have to worry too much if you did not do as well in the first and second question of section B. Okay, so now let's start with question B8 directly. Now they tell you that there are 2 main uses of ammonium nitrate. Thing number 1, take note that they're asking about ammonium nitrate, not ammonia gas. Okay, some of you wrote main uses of ammonia gas. I question mark, question mark. Now they ask you with evidence from the infographic. So meaning to say you have to refer to the infographic. You don't need to look at the news article. So that already tells you where to go. You're supposed to identify 2 users and suggest why ammonium nitrate is suitable for each use. So if I'm going to draw your attention to this area, okay, the infographic, okay, you'll realize that they tell you over here that ammonium nitrate's major use is in fertilizer because it's a source of nitrogen. It is also used in some explosive mixtures for mining and quarrying as an oxidizing agent. Okay, so over here they already give you 2 users, number 1 and number 2. There is no need to hunt for it anywhere else anymore. Now the problem is that some of you were not able to understand what is the meaning of the word use. Use means that we are talking about application. Okay, so for instance, you say to provide nitrogen. Providing nitrogen is not a use. Using as a fertilizer, that is called a use. Why can it be used as a fertilizer? Because it's a good source of nitrogen. So you must be able to differentiate between your use, which basically means application, versus your reason. Okay, now for the other one, some of you actually also for your use, oh shucks, what happened? Sorry, let me shift you a little bit.
Miss Go.
Yes.
Ishang said that you removed him from the meeting.
Yeah, of course I removed him from meeting. I asked him to turn on video, he don't want to turn on video.
Oh.
Okay, so for some of you, okay, the second one, you just stated that it can be used as an explosive. Now, being an explosive, that's not an application. An application will be you use it as an explosive mixture in mining or quarrying. So the application is actually the mining and quarrying part. Okay, and you want to be more precise about which part of mining and quarrying it's used for. It's used as an explosive over there. Now the reason will then be because it's an oxidizing agent. due to its nature of reaction, it is very explosive. Or you can say that when it actually decomposes, it releases a large amount of gas at high temperature, blah, 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 and therefore it can be used as an explosive. Okay, you can just refer to the mark scheme, and I think this one should be quite clear. Okay, moving on to the next one. Ammonium nitrate does not explode easily. It typically explodes under certain conditions. You're supposed to state first whether it's an endothermic or exothermic reaction. So everybody happily did what I have done. You highlighted endothermic or exothermic, but more than half of you did not highlight with evidence from the news article. So very specifically, we're already directing you where to look at, because we know that you're going to be very overwhelmed with the information provided. So go just to the news article, look for the evidence over there. So if you go to the news article and then you make the effort to actually read it, they actually down here tell you blah blah blah. Okay, all this information. Okay, so here is where they tell you the explosion released 1 gigawatts per hour of energy. So it released a huge amount of energy, and therefore, with the idea of it releasing energy, you therefore know this is an exothermic reaction. Okay, Ken? Okay, just now whoever who told me about the Isheng thing, can you please ask Isheng to join in again, then I'll admit him and tell him to turn on his video. Okay? And the people who have just joined us, please turn on your video now. If not, I'm going to kick you out of the room as well. Okay, Renhian, I know you always have video problems, so I'll let you be. But Ariel and Shaz, you have 5 seconds to turn on your camera now. Okay, what are the 2 conditions that cause ammonium nitrate to explode? Ariel, you want to say something, is it?
Oh no, my thing broken.
Your camera is broken, is it?
Yeah.
Okay, fine. Then I'll let you be. Okay, so we're looking at 2 conditions. Now, if you look at the mark scheme that is in your Google Classroom, you realize I've actually given you 3 possible conditions. These 3 conditions are actually scattered all across the news article as well as the infographic. I know it's going to be quite difficult for you to hunt them down. So that's why I asked for 2 out of the 3 only. Any 2, you would have gotten your 2 marks. So first, you can tell me that it's contaminated with impurities, because it's stated over there that when it's contaminated with impurities, there's a high chance of it exploding. Okay. Second one is that it is confined at high temperatures. So a lot of you actually thought that confined and high temperatures are 2 separate conditions, but they're actually both the same condition. Okay. If it's confined alone, meaning to say just kept together in a little confined space alone, but it's cool, it's not going to explode. If the temperature is high alone, but it is not confined, it's spaced out very widely, it's not going to explode either. So the only way that it's going to explode is that when it is confined and the temperatures are high. Okay, Ken? Now the third one is when it absorbs moisture. Now the moment it absorbs moisture, it starts growing into a huge rock. This is when it is likely to explode already. Okay? Okay, now next, during an explosion, apart from the impact of it, what is another harmful effect to human health? This one was not very well done. Firstly, you need harmful effect. Next, we are focusing only on human health. So those of you who told me things like what cause air pollution, this, that, global warming, that's all rubbish. Okay, totally will just be removed. Now, next, you need to actually state the effect. So some of you, good, you're able to tell me that nitrogen dioxide, which is a harmful air pollutant, is produced. But you then just say, oh, nitrogen dioxide is produced. It is harmful to human health. Full stop. Hey, hello, what's the effect? Okay, so you have to tell me what is the effect. In case you're wondering where did I find this piece of information, it is over here. Okay, it is actually over here. Now in this bottom part, they actually tell me that during decomposition, I'm releasing these other gases. So thing number 1, ammonia is actually not an air pollutant. Remember, we have learned our chapter on air and atmosphere. There are only those few: carbon monoxide, oxides of nitrogen, sulfur dioxide, methane, etc. Okay, ammonia is not one of them. Now, second, nitrous oxide. You're like, huh? is nitrous oxide the same as nitrogen monoxide? Is it a type of oxides of nitrogen? Not very sure. So I'm not very sure, never mind, because you already know for sure that nitrogen dioxide was one of the three main ones that you learned. So just focus on it. It causes breathing difficulties, eye irritation, full stop. Okay, and I only need one. So breathing difficulties is going to be the most straightforward answer you can give me. Yeah? Okay, I'm going to pause for a moment before I move on to part C. Any questions here? Okay, all of you look somewhat okay. I see Douglas and Ivan intensely writing down answers. Okay, good. Okay, next one, ammonia. If however, my heart broke when I marked this question. I thought I told you straight up, ammonia confirm will come up. And I even told you the few main things that you'll be tested on for ammonia. So I have no idea why when this question came about, I saw a lot of you giving me this. Remember, your chemical equation, this is a reversible process. So I should actually see you using the reversible arrows. Okay, now take note that in my mark schema, my reversible arrows actually look like this. Okay, in my mark schema, the one that you download from Google Classroom, the reversible arrows actually look like this. This one is not accepted. Okay, the only reason why I had to type in this is because in the Microsoft Word, I cannot find this correct one. Okay, in Microsoft Word, I cannot find this one that you should be using, so therefore I had to use the one in green. That is not accepted. Okay, this one is purely based on memory. You got it. If you made the effort to go and memorize it, you would have gotten your 1 mark. Okay. Now the next one, suggest how each reactant is obtained. Obtain means to say how we actually collect it. So, firstly, you talk about your hydrogen. Then you talk about your nitrogen. So how is hydrogen obtained? I already gave you a few examples. In fact, you should know 2. You just need to memorize 1. One is from your cracking of petroleum. Okay. The second one would be your electrolysis of water. Okay. You don't have to take it down so intensely now because all these are in your mark scheme. So you don't have to worry about it. Just try to make the effort to recall. Okay. Now nitrogen. Nitrogen, a lot of you told me that, oh, it comes from the air. Very good. Nitrogen comes from the air because there's a lot of nitrogen in the air. But how do we actually collect it from the air? So nitrogen actually comes from the fractional distillation of liquid air. Okay, quite a number of you actually did not write the word liquid, but I gave you a mercy mark for that anyway. Because if you're talking about air is in a gaseous state, there's no way you can actually conduct a fractional distillation experiment on just gaseous air. So it has to be liquefied. Can? Okay, the next one was actually not as well done as I hoped that it would be. Just now, whoever he did not come back in. He happily decided to just pontang, is it?
Cannot join.
Sorry?
He say he still can't join.
He said he still can't join. Okay, I don't care what his excuse. Ask him to go to our Google Classroom and go and look at the mark scheme from there. And tell him not to be silly again. Okay? Okay, now next. Let's look at part 3. Yeah? Part 3. Optimum temperature for the Haber process is 450 degrees Celsius with reference to the graph. So this was the part that some of you did not refer to the graph. You're very happy, you're very excited because Pisco said that yes, we know about this optimum temperature versus the one that is ideal and this and that. So you decided to just blah, 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 all your theory down. Your theory is correct, but your theory is only going to give you 1 mark. The other mark actually comes from referring to the graph. So now let's all look at the graph. Now 450 degrees Celsius is actually over here, which means to say that we are looking at this blue line. Okay, now what on earth are we supposed to refer? Talk about what? temperature is higher, your yield is actually much lower. When your temperature is at 500 degrees Celsius and above, do you notice that your yield is only so little? Compared to if your temperature is lower, if your temperature is 350 degrees or 400 degrees Celsius, do you notice that typically, regardless of what pressure you use, you will actually still get such a high yield of ammonia. So this question has nothing to do with pressure. They never ask you anything about the pressure at all. They're asking you to just look at the temperature. Okay, so you should give me some examples. You can either specify that, oh, at 500, 550 degrees Celsius, yield of ammonia is always below 30 degrees Celsius, regardless of pressure. At 350 to 400 degrees Celsius, the yield of ammonia is always much higher, between 50 to 70%. Okay, if you don't want to do that, the minimal thing that tell me that the higher the temperature, the lower the yield of ammonia. Or you can tell me the reverse, the lower the temperature, the higher the yield of ammonia. Okay, so at least I can tell that, okay, you've drawn some reference to the graph. Can? Okay, now once you've drawn your reference from the graph, we're then going to suggest, okay, so we know that the higher the temperature, the lower the yield. So why do we then use 450 degrees Celsius? Simply because if your temperature is too high, that means to say that the yield will be too low. But if you want a higher yield, you want to use low temperature, it then becomes too slow. Okay? So this is exactly the theory that we have learned already. Okay? So this one, I'll leave you just refer to the mark scheme so that you know exactly how you should write it out nicely.
What happens if my question says SIF on it?
Okay, SIF basically means it's a short input error. So for instance, you could be talking about pressure instead, or you could have given me the reverse trend. You could have told me something like the higher the temperature, the higher the yield. Okay, anybody else? Okay, if not, we're going to move on to question B9. Question B9, I think it was a pain for many of you. In case you think that Miss Koh was very mean to set something like that, I'm going to ask you to refer to the recent 2-3 years of TYS. Okay, very similarly strange looking questions on the periodic table have come out. So this should not be something that is too worrying for you. I'd rather you see now be shocked and stunned rather than O levels you see and then you'll be shocked and stunned. Okay, Ken? So yeah, all this information, I'm just going to skip. You have already pored over the information very long during the exam. So now let's take a look at the questions directly. Okay, so first, with reference to figure 9.1, state another error in the Shankutua's interpretation of the periodic table, making John feel that it's incorrect. So first, we want to go and see what John says. Okay. Now John says that, oh, he did not include the noble gases. So those of you who talked anything about the noble gases, immediately wrong, because it's not another error. Okay. Some of you, I'm going to look at figure 9.1. This is figure 9.1. Okay, figure 9.1 is here. Now some of you then talked about, oh, he did not include the transition metals. But remember that over here, you notice that he only talked about until sulfur. Until here, he only talked about until sulfur. He haven't even reached the transition metals yet. So no wonder he didn't talk about transition metals. Okay, so therefore, if you talked about the transition metals, that would also be wrong. So the most obvious error is actually in your face. Is this. You notice that there's NH4. NH4 very obviously is not. So just note that this is your error. Some of you actually called this ammonium. I would recommend you don't call this ammonium. Don't call it anything. Don't come and create your own name for it. Because technically ammonium does not exist. This was obviously a very old theory and it was obviously wrong. So in your answers, just write directly as NH4. Okay, so just say that the Shankutua included NH4, which is not an element. Full stop, you would have gotten your mark. those of you who decided to call it an ammonium ion, wrong. Because ion means to say it has to have a charge, but there are no charges over here. Some of you decided to call it ammonia. Wrong as well, because this is obviously not ammonia. Ammonia is supposed to be NH3. Okay, so this is where some of you lost marks for nothing. Any questions so far? Okay. So now over here, periodicity refers to element properties. So remember, periodicity refers to the trends in element properties with increasing periodic number. So this means to say that in your periodic table, periodicity is not just talking about your horizontal periods. No, periodicity is also talking about your vertical columns, because in your vertical columns, your atomic number increases as well. This is where you actually get your trends. Remember, we always talk about your group 1 trend, your group 7 trend, your group 0 trend. Do we ever talk about period 1 trend, period 2 trend? No, because in your period, there are no trends. It's just from metals become non-metals. That's it. There are no trends to speak of. So when we talk about trends, we should always be talking about your vertical groups. Okay? To discuss how periodicity was seen using the Shankhu-Tua's ideas in figure 9.2. So figure 9.2 is over here. Now I want you to notice, can you see that over here your lithium, your sodium, and your potassium, they are all just like 1 mm away from the edge. Okay? And at the same time, your magnesium and calcium, they are exactly directly on the edge. And if you look over here at your oxygen and your sulfur, they are both also directly on the line right above each other. Lithium, sodium, potassium, they are all vertically aligned. They all belong to group 1. Magnesium, calcium, they are both vertically aligned and they both belong to group 2. Oxygen and sulfur, they are both also vertically aligned and they belong to group 6. So this actually tells me that these things that he managed to vertically align, they have the same physical and chemical properties, or rather there is a similarity in terms of trend for these elements. Okay, so 2 things that I should see in your answer. First mark will come from your vertical alignment. Okay, I should see you telling me something about how the elements that are vertically aligned above each other or below each other, they all belong to the same group. Second mark, you should tell me that their alignment is actually the same order as the modern periodic table as well. Okay, so you should be talking about the order of the elements. So for instance, what do I mean by the order of the elements? If you refer to your modern periodic table and we look at figure 9.2 again, you realize that your first element of group 1 is lithium. First element, lithium. Second element, sodium. Third element, potassium. The order is the same. If you look at your group 2 first element, beryllium, but never mind. Next is magnesium, then comes calcium. The same. The order is the same. If you look at your group 6, you actually have your oxygen above your sulfur. So the order is correct. Okay? So therefore, for this answer, 1 mark will come from you telling me that all the elements are vertically aligned. The second mark comes from you telling me that the order of the elements is correct. Okay? So I am going to stop here. I will go through the remaining questions in our next session, which is tomorrow. I'm going to stop sharing for now. Anybody has any questions, please post in the chat. While you think about that, I'm going to ask you to do a second poll to reflect a little bit on your section B. Okay,